Alright, I hope everybody's doing well tonight. Welcome back to yet another edition of Exponents with Mr. Augustus. Today we're going to take a look at two new properties, negative exponents and zero exponents. So make sure in your notes that you get down both properties, the examples that go with those properties, and the three examples that are at the very end of this lesson. So first, I just want to kind of take a look at some patterns that we're going to notice before we jump into our negative and zero exponent talk. We've got, as you can see here, a little chart. We've got powers of 5, powers of 4, and then powers of 3 going down. And if we were to fill this out, I think we all know 5 cubed, well, that means 5 times 5 times 5. So that gives us a value of 125. And let's keep going with the powers of 5. 5 squared, 5 times 5 is 25. 5 to the first, well, we have one factor of 5, so that's 5. 5 to the 0 power. We're going to put that one off for a little bit, but try to notice the pattern that's going on here. Moving on to 4. 4 cubed, 4 times 4 times 4, 64. 4 squared is 16. 4 to the first is 4. Again, let's see if we can identify any patterns. And now with 3, 3 to the third is 27, 3 squared is 9, 3 to the first is 3. So here you can see, hopefully, a certain pattern, and it's based off of what it means to be an exponent, and to take some number and multiply it by itself this many times, to have this many factors or this many factors, of a certain base. So with 5, as you can see, from 125 to 25, 25 to 5, you're dividing out or taking out a factor of 5 each time. So if you were to divide this by 5, we're left with 1. Now let's take that one step further. 1 divided by 5, if we stay with that same pattern of dividing by 5 each time, dividing by 5, same thing here. So 1 divided by 5 would give us what? 1 over 5, or 1/5. You take 1/5 and you divide that by 5. Well, what's another way of dividing by 5? Hopefully you can think of multiplying by 1/5. It's the same as dividing something by 5, multiplying by a fifth. So if we had 1/5 multiplied to another 1/5, we're left with 1/25. So you can kind of see that 5 to the negative second is the reciprocal of 5 to the second. 5 squared is 25. 5 to the negative second is 1/25. Okay, similarly with 4, this would be 1. 4 to the negative first is 1/4, and then we have 1/16. This would again be 1. 3 to the negative first is 1 over 3, and then 1 over 9 for 3 to the negative second. So we can start looking at reciprocal exponents. The first property that we're going to take a look at is this zero exponent property, and we've got a column right here that has all of our exponents raised to the 0 power. The 0x property says this: any non-zero number raised to the 0 power is always equal to 1. Again, any non-zero number raised to the first power is always 1. Always equals 1. And again, the non-zero number is key. If it's 0, that actually is a little bit different. 0 to the 0 power is undefined. So a, as long as a here, this base, is not 0, as long as a does not equal 0, if we raise it to the 0 power, our answer is always going to be 1. Always going to be 1. Alright, we're going to take this one off here. Moving on to another thing, the negative exponent property. And sorry, go down there a little quick. If you need that zero exponent property, it's still up here. Negative exponent property says this: any number that's raised to a negative exponent is the reciprocal of that number raised to the positive exponent. And we kind of saw that earlier when we were looking at, or not kind of, we did see that earlier when we were looking at our chart, and we looked at like 5 squared being 25, and 5 to the negative second was 1/25. It was the reciprocal. And hopefully, if you remember from 6th grade or 7th grade math, when we talk about reciprocal, we're looking at switching the numerator and the denominator. So moving on to this example with a negative exponent, it's 2 to the negative 4th. The way that we can rewrite this without having a negative exponent is saying it is the reciprocal 1 over 2 to the positive 4th. So it's the reciprocal of 2 to the 4th, and we write that as 1 over 2 to the 4th. If you want, you can simplify 2 to the 4th. It's 2 times itself 4 times. There's 4 factors of 2 there, so that would give us 1/16. Next example, negative exponents. This one's a little bit different. We have 3 divided by x to the negative 5th. So in this case, our x to the negative 5th is down here in the denominator. And really what that tells us is we need to move x to the negative 5th up to the numerator. We'd write the reciprocal of it. And the 3 here is not being raised to a negative exponent. So 3 stays in the numerator, and then x to the positive 5th now comes up in the numerator, and this would be over 1, which is 3x to the 5th. So if you have a negative exponent, you must first make sure what the base is. In this case it was 2, in this case it was just x, and then move it to the opposite location. All right, we're going to talk more about simplifying expressions. An expression is considered simplified or fully simplified when it contains only positive exponents. That's why we're just looking at changing negatives to positives. So only positive exponents. Each base appears exactly once, so you can't have like an x squared and another x to the 5th somewhere else. As long as you have the same base, it can only appear once. And there are no powers of powers, meaning we don't have an exponent that's raised to another exponent. And the final thing is that all fractions must be fully simplified. All fractions in simplest form. So we've got 3 examples here that I want to encourage you to try on your own. So in a second, pause the video, get these examples down in your notes, and try to tackle these on your own. If you're really not sure how to start them, you can play the video because I'll work through each one as we go. All right, go ahead and pause it right now. Okay, hopefully you're able to work through some of these. If not, you can take a look at what I'll do as I'm working through them. So with this first example, we have x squared divided by 3x to the negative 3rd. So what I first must identify is what is being raised to a negative exponent. In this case, the only thing being raised to the negative exponent is our denominator of this 3x. So we can rewrite this using positive exponents. The x squared stays in the numerator. We don't change the x squared because it already has a positive exponent. And then we would bring up this term of 3x, and now it's raised to the positive 3 because it was the reciprocal, so we bring it up to the numerator. And it's now raised to a positive exponent. So, simplifying this, you should remember from earlier in the week. The x squared, I'm going to keep out in front. 3x to the 3rd is really the same as 3 to the 3rd times x to the 3rd. Everything in here is raised to the 3rd power. So 3 to the 3rd, we should be okay with knowing that that's 27. And we have 2 factors of x here. We have 3 factors of x here. So that is x to the 5th power. So our final answer here, simplified, is 27x to the 5th. Moving on to example 2, you have n to the negative 5th, r to the 4th, divided by r to the negative 2nd. So again, the first thing is identify what bases have negative exponents with them. We have n to the negative 5th and r to the negative 2nd. So those are the ones we need to switch. R to the 4th still stays in my numerator. We then would bring up r to the positive 2nd, it would change signs, and n to the 5th would go down to the denominator, my apologies, n to the 5th we'll go down to the denominator and make it a positive exponent. Then we can combine these terms up top, 4 factors of r, 2 factors of r, that's r to the 6th, all over into the 5th. And that would be my final answer. And with this last one, what I first would do again is look at the negative exponents. So moving our exponents, the negative ones, to the opposite location and making them positive would make this 5, still stays up here. The only thing that was raised to negative is r to the negative 3. And we still have t to the 4th in the numerator. The only thing down here that's negative was u to the negative 5th, so we'd bring that up and it becomes u to the positive 5th. Down in my denominator, we still have the negative 20, we still have the r squared. And then this r to the negative 3rd would be moved down here and become r to the positive 3rd. Now, let's look at simplifying. 5 divided by negative 20, that's the same as 1 over negative 4. So, it's 1 t to the 4th, u to the 5th. So we have t to the 4th, u to the 5th, all over negative 4 r to the 5th.